Hello and welcome to my Devdas era. In this video, we will talk about coding assistants. So coding assistants are the rage in 2024. It feels like we're entering an era where it will be very easy for anyone to code. So in this video, I want to talk about number one, the various types of coding assistants that exist, what companies are popping up in this space. Number two, why I am not super bullish on them just yet, why I haven't incorporated them in my workflow. And lastly, we will go through a real world problem. I'll try to solve it myself without any coding assistant. And then we'll try all types of categories of assistants. We'll see which one was the fastest, which one was the most convenient for me to use right now. So let's start with the meta section of this video. I think broadly, there are three types of coding assistants. Number one, a chat GPT like UI, where you first copy over your problem, contextualize it and paste it inside a web-based UI. Finally get the response, copy over the response and paste it back into your IDE. This is the most basic thing that frankly existed for a while now, and you might have been very comfortable in this workflow. Frankly, I am as well. If there is one assistant I use right now, it is copying over the problem from Visual Studio Code or whatever editor I'm using, pasting it in ChatGPT, giving it some context, and then getting back the response and pasting it back. The pros of this are, number one, it's very easy to see what's happening. There's no magic here really. There's an LLM that's out there, it's closed source, and you interact with it through a UI. Downsides are, of course, there is more time for you to copy paste code. There's a lot of manual work that you have to do to copy over code from one place to another. I still feel this is the one I'm most bullish on right now. And surprisingly, this is the one that I've been using a lot compared to the other options. Category number two. This is basically some sort of a plugin in your IDE, for example, a VS Code plugin, which is just a wrapper on top of a closed source model. You might feel like this is a 10x better solution than the first category, but the problem is the AI tries to get a lot of context itself. If you start to write your code, you're not really telling the AI what to do. It sort of figures that out itself. And downside there is it hallucinates a lot. It starts to type things that you might not need, which becomes mildly irritating. This is the reason I've not flipped on GitHub Copilot in my IDE ever, because I don't want suggestions that I don't need. If I need a suggestion, I'll copy and paste it over to ChatGPT UI. So that's the second category. I find it mildly irritating right now. It felt like a 10x product. I don't think it is just yet, but we will see where this market goes. Number three, this is a new category. This is one I'm not necessarily bullish on, but I'm excited to see, which is still a plugin, but it's on an open source model that you can run locally. It still has the cons of the AI trying to figure things out itself. But if you're running a model locally, you can do 10 different things that you cannot with a closed source model. This I'm excited about purely on the technicals. I still feel this is not a 10x product yet, but at least a step in the right direction. I can start to customize my model in a way where it starts to write code like I do. So I don't have to give it additional context like I have to do in category number two. All right. So those are the three categories. Number one, very ad hoc way of copy pasting code over to a UI. Number two, a plugin that's a wrapper on top of a closed source model. And number three, a plugin that can hit any model of your choice, including a model that is running locally on your machine. Given these categories of assistants, let's move to the next section where I want to talk a little bit about why I am mildly bearish on them. Don't actually code. And I think a similar wave came when no code tools came into the picture. Now anyone can write or create websites because it's a no code tool. You drag and drop, you create a website. The problem is you're able to create a very basic version using these things. As soon as complexities arise in your code base, no code tools are usually not the best solution. Eventually you have to code things yourself. I think after years, people have come to realize that this is true and you can use no code tools for basic landing pages, but as soon as you start to build a real website, you're no longer dependent on them. I think something similar is happening here where a category of developers who've never coded and, maybe don't code too much, can suddenly see code being typed out. But the problem is as soon as complexity comes into the picture, the AI may or may not hallucinate, but you at the very least need to understand what the AI is writing. And when that happens, you'll eventually get frustrated. If the AI can write a lot of code for you, but if you don't understand it, you'll be always anxious checking it in. You'll be always anxious trying it out. So for that reason, as fancy as it might sound, anyone can be a coder right now. If that was really true, then literally everyone would be a coder and, the whole supply demand arbitrage would close. Eventually, some smart coders will find a combination of one, being technically strong themselves, and two, using these assistants wisely to be a little bit faster. And this combination might be the next wave of smart developers. I don't know yet, but I don't see any senior developer being super excited about this right now. It does save time. I'm not saying it doesn't. I'm saying it's not really an assistant. It's not really someone you can delegate everything to, which sort of was the original pitch of replacing developers. All right. That's point number 2. Now let's look at a very basic project which has some issues that we should fix. I explained the project at a high level, but there is a link in the description where there is a detailed workflow of how you can create this project on your own. It's a simple MERN stack project. It has some inefficiencies. I wouldn't call them bugs as such, but some good to haves. So let's try to fix them. Number 1, ourselves. Number 2, using ChatGPT UI. Number 3, using a plugin that hits a closed source LLM. And lastly, a plugin that uses an open source LLM that's running locally on my machine. Let's get right into it. All right, let me give you a brief of the project we're dealing with. You can actually go to this link in the description and there will be a detailed lesson of how you can create this project on your own. This is actually part of the cohort. You won't get access to any of the videos, but if you want, you can try to code this thing yourself. This is a basic financial app similar to Paytm. It looks something like this. You can sign up or sign in if need be. Once you've signed up to the website, do that. You reach a page where you see a bunch of people that you can send money to. You also see your own balance and you can search these users, select a user and send them some money from your wallet. And once you do, the transfer sort of goes in. You see a bunch of inefficiencies here. There are no notifications. In fact, the balance that you see here is hard coded. So these are the problems that we'll try to solve. It still works. The database still, decreases the balance of one user, increases the balance of another user, but the UI doesn't reflect that. So let's break down a few problems that we can fix here. And then we'll try to fix them. We'll time ourselves in how much time it took us in each of these categories when we were using assistants and when we weren't using assistants. The first problem that we should fix is it's a very minor inefficiency, which is, when you go to the landing page, you pretty much see nothing. If you go to the sign up page, even if the user is already logged in, which I was right now, they stay at the sign up page. They should ideally go to the dashboard. Similarly, if the user isn't logged in and the URL tries to go to the dashboard, they should not see this page. They should go to the sign up page. And lastly, I think the balance should reflect correctly. So this is a hard coded value of 10,000 rupees. We should fix this to the current balance of the user. Let me give a high level of what the database looks like, what the backend looks like, what the frontend looks like. It's a very basic MERN application, doesn't even use TypeScript. It's in pure JavaScript. And if you read through the code, if you understand a little bit of MERN, you should be able to understand the whole thing pretty easily. All right. The database looks something like this. There are multiple users. So whenever you sign up, there's an entry created for you in this database. And then there's another entry where you get a random balance initially. So there's no way to really on-ramp via banks here. So everyone has a random set of balance. This is MongoDB. And as you can see, the first user has, for example, 5,800 rupees, second user has 720 rupees, so on and so forth. Given you have this and this, anytime the user goes here and sends some money, clicks on initiate transfer, the money gets debited from one account and credited to the other account. That's how things work right now. The problem, let me summarize again, is that number 1, we need to redirect user correctly. Number 2, show the right balance. All right, these are the 2 problems we need to solve. And here, before we dive into the code, I want to talk a little about where assistants are pretty much of no use. I think when you're given a problem statement like this, it is you, the developer, who will decide how to design it. For example, in this specific case where, forget the balance for now, but the other thing that we need to implement, which is if you're on the sign up page, and if the user is already logged in, they should go to the dashboard. There are multiple ways to implement this, and I'm not saying the AI will give you a wrong solution. Number 1, it will be very hard for the AI to span across files, frontends and backends to understand this. Maybe that changes in the future. But secondly, there are 1,000 approaches that you can take here, and developers are generally very finicky. Teams generally have standards/practices. Maybe you can codify these practices, I don't know. But currently, in the current scenario of how teams work and how coding assistants are, I think there are a few decisions that an engineer needs to take. They can make the AI code a bunch of things, but there are a few decisions that I'm going to talk about now to implement a feature like this. Not only I decided, and this is how I want to implement them. Another user can implement it a different way, and an AI can totally, use a different way to implement it. So this is one place where I feel you at least need a manager, an orchestrator, a person who, number one, understands how to code. Number two, can either make the AI code or can code themselves. That really depends on them. But they need to know. They need to be the final decision maker on how this feature needs to be implemented. Cool. That's another reason I feel it's not super bullish for us to feel everything can be outsourced to an AI. I think most things can. I think one person engineering teams might also exist, but in the end you need one engineer or orchestrator who can talk to AIs. All right. With that small moment of relief, let's get into how we can solve both of these features. So the first thing we need to do is whenever the user hits the website, irrespective of what page they are on, sign up, sign in, or dashboard, or even the landing page. If I'm being honest, if the user is on the landing page, they should go to either the dashboard or the sign in page based on whether or not they're logged in. The first thing we need to do is hit the backend and check if the user is logged in. You cannot do this on the front end. Your cookie can expire, which in our case we don't have a cookie. We have a token, but either way, it can expire. So you can't really assume the user is logged in if you have a token on the front end. You need to hit the backend. So the first thing we have to do is, for the first feature, create a backend endpoint. Again, if you don't understand it, it's fine. Just look at the lines of code that I'm writing and how quickly I'm writing them myself and how quickly the AI does it. Secondly, on the front end, hit this endpoint and redirect the user correctly. All right, these are the two things we need to do for the first point. For the second point, that returns the user details and maybe the balance. Second point, just use the endpoint defined in 1A. So we don't have to do much in the second point, if I'm being honest. If you already are creating an endpoint, which the user needs to hit to check whether or not they're logged in, you can just return their balance from the backend in the same endpoint, which basically means whenever the user comes to the website, we're going to hit the backend. This is the backend and this is the browser. Irrespective of what page the user came on, the browser will hit the backend and ask for, am I logged in? If yes, what is my balance? And then the backend will return either a yes or a no. And if it is yes, it'll return the balance as well. Let's say rupees 3,000. All right. This is one endpoint that we need to create, and this will basically solve both the problems. If you get back a yes, you take the person to the dashboard, or you keep them at the dashboard if that's the endpoint that they hit. Or if what you get back from the server is no, which means the user isn't logged in, you take them to the sign in page. All right. Cool. Given this, let's kick things off by timing myself. I'm going to code all of this. We'll probably speed ramp it. You don't have to look at the whole thing for this video. And then we'll see how much time it took me. Then I will flip on the assistants, first ChatGPT, then closed source, then open source. And then we'll see how much time those take as well. All right, let's kick things off. I'm going to start the timer now and code this problem really quickly. So the backend is done. I don't know how much time it took. Let's go to the front end. Done with the first part, almost done-ish. If I go to the index page now, it automatically redirects me to the dashboard. You can look at the clock there and see how much time it took me to implement this. Next up, I'm going to implement the balance endpoint. Should be straightforward if you already have the data. balance is done. Let me quickly clean up all the routes and then summarize all that I've done. All right, I think we can stop the clock. How much time did it take? Roughly, it took me 9 minutes to solve all these issues. Again, let's summarize what the issues were. The issues were: number one, we needed to redirect the user correctly. If you look at it now, if the user is logged in, which this user is right now, if I go to /signup, I automatically get redirected to dashboard. If I go to the index page or the landing page, I again come to the dashboard. And then if I go to the sign in page, same thing would happen. And if I go into incognito window and try to go to the dashboard, it takes me back to sign in. So the user on the front end is being redirected correctly to the respective page, which is something that wasn't happening. Second thing that has happened is the balance looks correctly here. This was 10,000 hard coded. Now it's the real value from the database. Let's figure out how did this happen. Let's break down all the things that I did. Number one, I went to the backend and created this route. I don't know how much time it took me, but I would assume less than 5 minutes. The me endpoint. This is the point where I want to say, everyone can have their own set of opinion as to what they want to call the endpoint, or even if they want to go with this approach. The approach that I took was, anytime a user comes on the website, irrespective of what route they are coming on, whether they come on the sign up page, sign in page, or the dashboard page, the first request that needs to go out is to this me endpoint that gives back the user details of themselves, whether or not they're logged in. If they're not logged in, they should get back a message that says you're not logged in, not get back any user details. If they are logged in, they should get back, you are this user, this is your balance. So these are the things that I return from this endpoint. There is scope of improvement here now that I look at it. If I'm being honest, this whole project is in JavaScript, and while I was typing the code, I think I would have anyways been like at least 25-30% faster if the code was in TypeScript. That said, I think this is arguable as to who writes better code, whether an AI would give me a better code, I don't know. But this is a good start. This took me, I think 3-4-5 minutes. Once I wrote this is the backend code, all the backend code that I needed to implement all the features I needed. Then I went to a bunch of files and I realized, I can make a lot of changes in a bunch of files, but rather let me put everything inside a hook. This is another thing I'm unsure if, an AI can get context on immediately. You will ask the AI to code something for the first page. For example, you might ask the AI, when the person goes to the slash page or the index page, take them to dashboard. And the AI might shove all this logic that you see here that I put inside a separate place, because I am an engineer. I can think in the future, I'm going to need this logic in 10 different places. Let me encapsulate it up front in a hook. And AI might not be able to do that. So you might ask the AI to write something and it might shove all of this logic in another component. For example, the index component. So basically all these files would look so big. Versus I encapsulated all of this into a single hook because I could sort of think in the future. I don't think AIs can do that yet. This is another place where you might need human intervention. I'm not saying the AI is bad. The AI would have been actually pretty good. We'll see in the next sections. It might have been able to spit all of this out. But putting that into a separate file is still the job of a developer, and I'm unsure how much time it saves. Once I did this, I made the same change in a bunch of other components. For example, I went to the dashboard component and added this logic at the top. I went to the sign up component and added this logic to the top. Same for the sign in component. Basically make sure everyone gets redirected correctly. And lastly, in the dashboard component, I already had the value as a hard-coded value here. I replaced it with user.userdetails.account.balance, the thing that we get from the backend. Roughly took me 10 minutes. It seems pretty straightforward. I think it would take this much, maybe 2 minutes less, 2 minutes more for anyone to code. Now that we have this, let's see how much by the way, I had the assistant on throughout. I did not use it. When I was typing it, I started typing, I realized, it was on, which is fine. I did not use any of the suggestions it gave me. But in the next section, let's actually flip on either Copilot, or I have this other one called Cody here, because Cody lets you hit both closed source and open source LLMs. We'll use either one of them. We can do Copilot. So let's do Copilot in the next one, which uses GPT-4, which is a closed source LLM. Let's see how much time it takes for me to write the whole thing again, if I'm using a closed source LLM like ChatGPT. All right, let's get into the next section. All right, hands up. 2 minutes I saved, but there's some downside. All right, let's quickly discuss what all happened here. I have a few fresh thoughts in my head. Number one, the backend code was smooth. It took basically a tab. I think I saved 3 minutes at the very least, if not more, compared to the original approach. Again, we're using Copilot with GPT-4 here, or 3, but I'm probably 4. Yeah, I think it's 4 by default. So pretty good. The backend code, super impressed. I thought, this video probably might not make any sense, purely based on how quickly it happened. But then when we came to the front end bits, the cracks that I was talking about basically came, which is number one, did not write extremely reusable code when it comes to, I went to again the index endpoint here, and then it was not smart enough to figure out to encapsulate code, which I guess is fine for now. I mean, it's an LLM, it knows. It's not yet an agent. It's not yet taught to, think smartly. It's taught to spit out a lot of code, which it did. But the common cracks were, rather than passing in this header, which is something that I've passed in different files, so I would have assumed it uses. And also I've been using Axios in different files. It did not use Axios, it uses fetch, and it had this code, which means it was expecting the cookie to go out, but we don't use a cookie, we use a token. So those are the things it pretty much copied from a different code base, I'm assuming. This was 3001 and not 3000. Those were the small things that, needed fixing. And lastly, here it checked if data.id does not exist, then navigate, or data.id exists, then navigate to the dashboard. But from the backend, it wasn't putting in ID. It basically tells me, it's not very context aware of the code that it wrote itself. It basically does not remember any of the code it wrote. I'm sure it will at some point, as it does look at files that I could understand. So it's able to, once I wrote this code, basically it was able to actually, write similar code in other components. So if I go to, dashboard.jsx, all this code it wrote itself, which basically means if you tell it once, okay, this is how auth is happening for me. This is my backend endpoint. It figures out things for the other files itself, which is good. But again, I wouldn't, if you're a good developer, you wouldn't write this code again and again. You would shove this all into a different file. So mixed opinions here. Overall, at least on the backend, it was super helpful. On the front end, was mildly irritating at points. But I think I would be fine with the irritation. Basically, I think I should flip this on for myself because I haven't yet. And now it feels like at the very least, it'll give me some productivity boost. And if it does not, you can always flip it off. But more specifically, you can just ignore the suggestions that it's giving. And at some point, you probably have to go all hands on deck and teach the AI, or at least tell it to do something different. This is where I feel a junior engineer or someone who's not coded will pretty much accept what the AI is giving it, and that's where the problem arises. Cool. This was number 2. 2 more experiments we're left with. Third experiment is going to be using ChatGPT UI. So I'm not going to use this, but use the UI to solve it. It seems like a futile experiment, if I'm being honest. Will most probably take a lot of time in copy pasting. I can almost certainly tell you, it'll be a longer time duration. Also seems like a very fake experiment. Happy to do it, would urge you to do it. I'm probably not going to do it. So I'm going to do the last experiment, which is a closed source LLM. This one's super interesting. This wasn't possible until a while ago. I think there are a few companies now who are trying it. Cody is one of such companies. Even though this video isn't sponsored, I think they're onto something. With at least giving people the power to use closed source LLMs. Open source LLMs. The reason is, that at least excites me personally. If I have a tool that lets me connect to an open source LLM, I will do 10 different things to train the model a certain way so it understands this is how I code. And there's some, technically exciting problem for me versus, everything else seems a little bit of a, wrapper on top of GPT. So with that, let me show you quickly how can you turn on an open source model locally and connect it directly to VS Code. I think it's possible, might be possible using various tools. The one we're using is, where did it go? This one right here called Cody AI. So the first thing you have to do if you're in Visual Studio Code, and I think both GitHub Copilot for sure. I'm unsure if Cody AI exists for other IDEs. So this isn't necessarily restricted to Visual Studio Code. you can try it like a NeoVim or a JetBrains IDE as well. I'm going to flip off GitHub Copilot chat. I'm going to flip on Kodi AI here. If you want to try it out, just install this extension and then go from there. There are a few tweaks you have to make though, if you want to run the model locally. So the first thing you have to do is get the model locally. There are a few open source models. Llama is the most famous open source model by Meta, and it has a fine-tuned version for coding. That's the one that we'll be using today. The way to bring that model locally on your machine, there are a few ways. The most popular one these days is something called Ollama, which is a project I think by a few folks who used to work at Docker, that lets you to bring LLMs locally, open source LLMs of course, and very similar to Docker. How Docker lets you pull Docker files, I think they wrote very similar code because the UI looks pretty similar, or the CLI looks pretty similar. So you can pull open source models, for example, after you install Ollama if you want to try it out locally. If I go to my terminal, what's up here? If I type Ollama, Ollama list gives me a list of my currently available models. So you can pull any famous open source model locally if you want. All you have to do is Ollama pull name of the model. For example, I have CodeLlama 34 billion code model and also Ollama 7 billion code model. I'm going to use this one. I'm trying my best to run this. I'm not been able to. I think it's a bug or an issue with Codium. It is by default. This is the one that I pulled first. And then ever since then, it's been using this. How do I know it's been using this? Because it's, I can see it in the logs. I'm unable to move from this model to this model. I think this one might perform slightly better. This one I tried a while back. I can give you a TLDR. It was pretty poor. Every suggestion was very bad. So we will see. I mean, it gives you good suggestions for very simple stuff. So if you, the standard example when you're trying to test these LLMs, coding assistants is make it solve a simple problem like sum. Function, something like this. This it was able to solve pretty well. Let me flip it on quickly. This it was able to solve pretty well. But when it comes to actually coding things like, creating a route, it pretty much shit bricks. You will see very soon. So let me start the clock again and let me try to solve this whole problem. Now using a open source model that is running locally on my machine using Kodi AI. If you want to flip it on your side, it's a few things you have to do. As I said, number one, you have to install Ollama. Number two, you have to pull in the model that you want to run. And number three, if you go to this icon right here, which is the Kodi AI icon, you can go to settings. And oh no, that's GitHub Copilot. That's my bad. That's Kodi AI. If you go to settings, you need to select unstable Ollama here. The name itself is unstable, so there are no guarantees this will work. And if it does not work, you can look at the output here. You'll find some error. For example, I did not have the 7 billion model. I deleted it, and then I could see the log here. Okay, it should bricks, and then that's how I knew I wasn't getting any suggestions. Right now, I am getting suggestions, so I know it is working, and it is all of this is coming from this CodeLlama 7B model. How do I know this? I can see this somewhere in the logs. If I'm being honest, let's see. Let me go to settings. If I go back here and select null, which basically means switch back to, it says Codebase here, but I'm assuming GPT. And then if I select unstable Ollama again, no, I don't see any logs. There we go. I think it was happening. I think the logs were just going down. So now the log clearly say Kodi completion provider initialized unstable Ollama / CodeLlama 7B code. This is the model that I have running locally. And now most probably it's very hard to confirm this is the model that's running locally. 99% it is. You might suggest just turn off the Wi-Fi and it will happen, and know that does not happen. Turning off the Wi-Fi still creates issues connecting to this local model. I'm assuming because they hit their own Kodi APIs from time to time. So I'm 99% sure this is hitting the local model. The reason for this is number one, the speed. Number two, the accuracy is pretty bad. If you have the normal default GPT model, which I think is GPT-4 is what they use, the accuracy is pretty high. Here the accuracy is pretty bad, which is why I'm 99.9% sure This uses the local Olama model that I'm running, which is this 7 billion parameter model. And now I'm trying to code the whole thing again using just this. All right, one quick disclaimer: if you're trying this locally, make sure you flip off GitHub Copilot, else you will see suggestions from Copilot, which is something we don't want. All right, let's move on. All right, I take a pause and I accept defeat. I don't think this model, at least the one that I'm running locally, it has a few problems. Let me state the problems from the top. So it took me around 5-6 minutes to, I wouldn't say finish it. I'm not close, but I'm basically not able to achieve what I want to. I'm just copy pasting code, which basically means I'm doing the approach one again, which is something I don't want. I wanted to rely completely on an LLM, and right now I cannot rely completely on a open source LLM. If you're someone who does not know coding or knows a little bit of coding, this is not the right way to go. It'll just, you'll pluck your hair out. So let me explain the problems from the top. If I go to user.js, router.get/me, this endpoint that I created basically required a lot of manual effort. The initial endpoint that it gave me had a find by PK here, which I think was an old Mongoose API. I could be wrong, might still exist. But that is one thing I had to change. This was wrong. Basically did not have any context of the auth middleware, which I guess is fine. It's still fine. I mean, there was a bunch of manual effort required here. It was still able to spit out pretty good code, which I was surprised by. I thought, it won't be able to based on my earlier experiments of running it locally. But right now it gave me a good structure. Few things missing, it's fine. I think it took me like 2 minutes to fix the whole thing. Of course, I did not fix everything. There were some bugs here that I had to come back to. But high level to level, maybe equivalent to or better than writing all the code yourself. Not as good as Copilot or GPT-4. Go to the front end now. Front end was a little tricky. Basically all of this I would say is pretty much written by me. Wasn't able to figure things out. It's still wrong if I'm now that I'm looking at it. So yeah, basically at this point I realized it cannot write front end code very well, if at all. So I still wrote everything here, and it's fine that I had to put in some manual effort, but it did not even keep context of this. So once I wrote all of this logic, it should have at the very least been able to rewrite this logic in dashboard. But when I preached here, it is hallucinating again. It's pretty much giving me something that's not related to the code that I've already written, which basically means it's better to just write it yourself. So what is the final outcome here? Coding it yourself, great, but you should probably use an AI. What AI should you use? Should you copy paste over to ChatGPT? If you're a little too old school, sure. If you're still in love with Stack Overflow, sure. But what should be your ideal solution? Unless you have company policies that prevent you from looking at GitHub Copilot, use GitHub Copilot or some wrapper on top of GPT-4. Seems like GPT-4 is 10 times more powerful than at least the 7 billion parameter model. I could be wrong and the results might change. If you use the 34 billion model, happy to try it out after this video. I'll see if I'm able to somehow make it work. And yeah, that might change my opinion. For now, basically open source models, at least 7 billion model is not even close to, which I guess is already known. It's nothing new here. I think this can compete with GPT-4. That said, it seems like Copilot at least was making the model learn along the way, which this guy isn't, which might not be a problem specifically with this model, might be a problem with, Cody AI. So yeah, that's another thing. It should probably retain some context of the code that I've written, and, at least the code that I've written in the past 5 minutes or 10 minutes. These are all ad hoc techniques. I'm unsure if this is how GitHub Copilot does it. But if you want to look at the code base, I think Cody AI is open source, so you can. Yeah, that's a high level from this video. What's been my learning? My learning has been GitHub Copilot way to go. I think that's what 90% of the people are using anyways, because of, just pure branding, marketing, of GitHub. That said, it also seems like the more superior product at the moment. We will see if that changes, but I think that brings us to the end of this video. Was I sharing my screen? That brings us to the end of this video. Hopefully it was an insightful video. Let me know what should we do next. Should we dive into the code of Cody AI and see how they were able to do? It seems like it's a simple VS Code extension with, a bunch of GPT. I'm being a little premature here when I say simple, but we can look at it and just try to figure things out ourselves. Let me know if you want, but we can look at it, try to figure that out ourselves. Let me know if you would like to see that next. With that, let's send it. I'll see you guys in the next one. Bye bye.